So today what we will do is, see, last class we saw the fourth state of matter. Then we'll look into the fifth state, and then we will look at question answers. We will have a summary of all the points that we have studied in this particular chapter, and followed by the question answers. And then whatever we discussed, some of the points, like for example, dry ice, then we have how clouds are formed, that we will have a small presentation. Okay. Okay. So now we will start with we looked into the fourth state of matter. Now we will go back to that again. So we'll start with Aishwarya. So from your textbook, you read the fourth state of matter.
Plasma. The state consists of super energetic and super excited particles. These particles are in the form of ionized gases. The fluorescent tube and neon sign bulbs consist of plasma. Inside a neon sign bulb, there is neon gas, and inside the fluorescent tube, there is helium gas or some other gases. The gas get ionized, that is, gets charged when electrical energy flows through it. This charging up creates a plasma glowing inside the tube or bulb. The plasma glows with a special color depending on the nature of gas. The sun and the stars glow because of the presence of plasma in them. The plasma is created in stars because of very high pressure.
Very good. So we are seeing plasma one in our daily life, second plasma in nature. So Aishwarya, what did you understand from plasma in our daily life? Where are we seeing it? Okay, the first part. What did you understand from what you read now? Okay, what is plasma?
It is super energy. It contains super energetic power, ma'am.
Super energetic. They are made up of super energetic particles. So where do we see it in our daily life? What you just now read, no, fluorescent tubes, like our it is electricity or neon lamps. Okay,
it is present in fluorescent tube and neon sign bulbs, ma'am.
Okay. Fluorescent is our what do we have usually? Our lighting. What are the sources of light that we have? Anyone? Where do you think we see this fluorescent tube in our daily life?
Bulb.
So tube light. So tube light, you can see, yeah, some of the bulbs also. You have this, that is a fluorescent tube. So it contains gases like helium within it. Whereas neon, what is it? Neon bulbs are? Neon bulbs, how does it look? From whatever you read, what does it tell about the neon bulb? So, okay, we can summarize as plasma, they are charged particles. So, when electricity is passed through them, they get ionized and they are supercharged. And what happens is, depending on the property of the gas, depending on the nature of the gas. So, we are having this gases like neon, helium, argon. These filled into the bulbs or the tubes.
Noble gases, ma'am.
Noble gases, exactly. Very good. So in noble gases, we are passing electricity, they get charged, and depending on the property and the nature of the noble gas, we get different light. For example, neon, in case of neon bulb, like you have a particular color. In fluorescent, what they do is they have helium, they fill helium, and then they coat the bulb. That is why it looks white. So they coat the bulb with phosphor. So as a result of which you get that white, nice, bright white light. Okay. So the point here is these are plasma. They are charged particles. So charging is we are bringing about charging. We are making them ionized. We are making them have a lot of energy. We are passing electricity. Okay. So noble gases, are they stable, Farhan? What is the property of the noble gases? Noble gas one, okay,
It is
neon, for
stable,
example.
ma'am.
It is stable. So when you're passing electricity, what is happening? What do you think is happening? Anyone? You can just guess. Say you are having an inert gas. So I'm passing electricity through it. What can happen? So you're affecting the stability. Okay. So you're affecting the stability. So it gets ionized, loses. That is, it gets ionized, and when it gets ionized, it starts like, you see, what we see is it starts moving, and that energy we see in the form of different colors, or in case of fluorescent lamp, we are seeing that fluorescence because of the property of the particular gas, and also in case of fluorescent lamp, a coating that is present. Okay, very good. So this is what we know. We man-made. This is man-made. In nature, where do we see plasma? Who will answer?
In stars, ma'am.
In stars, and also in sun, we see the like, because of heat. So heat energy is ionizing the gases that are present, and we see from here. Okay, my question is, why do stars twinkle?
Because of plasma, ma'am.
Because of plasma, they're emitting light. Correct. Okay, they're emitting light, but they keep twinkling. No, sun is nearby, so we can't look at the sun. There's so much of heat and light is generated, we can't look at the sun. But stars are far away, so we are able to look at the stars. Okay, star is, as you said, plasma is there because of heat, light is generated. Okay, but why does it twinkle? You can think, any idea for? Any guess? It should come. It should come in a straight line, no? But stars, you can see there'll be, close, like, there'll be like there is what is called as dispersion of light. Okay, why do you think dispersion of light should occur? You studied about diffraction of light in your physics? Diffraction light. You're not studied? Farhan, yes or no?
No, ma'am.
Okay. Anyway, then okay. In that case, actually, dust particles are there in the atmosphere, so they'll go on. The light will. It cannot travel straight because these particles are in the way. So as a result of which, they get scattered. That is one phenomenon you'll be studying in physics. Okay. So thus now plasma is the fourth state of matter. Okay. Now we look at the fifth state of matter. Anjali, continue from where Aishwarya stopped.
Bose-Einstein condensate. In 1920, Indian physicist Satyanath Bose had done some calculations of the fifth state of matter. Building on his calculations, Albert Einstein prepared a new state of matter, the Bose-Einstein condensate. In 2001, Eric Corel, Wolfgang Ketterer, and Carol E. Williman of USA received the Nobel Prize in Physics for achieving Bose-Einstein condensation. The BEC is formed by cooling a gas of extremely low density, about 100,000 the density of normal air. To super low temperatures, you can log on to www.chem4kids.com to get more information on these fourth and fifth states of matter.
Okay. So Anjali, what did you understand from this? Anything like, this fifth state of matter is made up of what? Forget about the names. Bose you forget, Einstein you forget the names of the Nobel Prize winners. But what is, if you, in simple words, what can you tell? Can you think and tell?
In 1920, Indian physicist Satyendranath Bose done some calculations for a fifth state of matter. Based on his Einstein prepared a new state of matter. The BEC is formed by cooling a gas of extremely low density to super low temperature.
Very good. So, okay, the fifth state of matter is made by taking the gas of very low density and cooling it, super cooling it. So we are getting the fifth state of matter. Okay, so very good, Anjali, good effort. Okay, so we have seen the three states: solid, liquid, gas. Fourth is plasma. We are seeing it in our everyday life. And fifth is the, what you call, the one that has been super cooled. That is a very less dense gas has been super cooled, and we are getting the fifth state of matter. And for this research work, they got the Nobel Prize. So this only tells us that how more and more research is being done. Now they have also found out the sixth state of matter. So like that, the more and more research work is going on. Okay, so we have got an idea about all the states of matter and how the matter. See, what we have to remember is this properties of states of matter. What are the inherent properties of matter as such? What are the three important properties of matter? Can someone tell me quickly before we go to the summary? Three properties of matter. Who will tell me?
Ma'am, can I?
Ma'am, can I tell?
Okay. Okay, first person. Aishwarya will tell the first property of matter. What is it, Aishwarya?
Particles of matter have spaces between them.
Very good. So they have particles of matter, they have spaces between them. Second property, Anjali.
Yes, ma'am. Particles of matter are continuously moving.
Yeah, very good. They are in constant state of motion. Third, I heard Farhan. Third property.
The particles of matter had a attraction power between them.
Yeah, they have force of attraction between them. Because of the force of attraction between them, we have solids, liquids, gases. We have seen that dance as an example. If the force of attraction is more, you are having solid present. In solid, that is the in constant motion. What is the term we use for constant motion, students? Particles are in constant motion. For that, what do we call? What word do we have? They possess
Uniform motion.
that is because of what? Okay, the uniform motion is because of what? Because of they have inherent
kinetic.
Very good. They have kinetic energy. So this kinetic energy again depends on the space between the particles. If the particles are close together in solids, they don't have much kinetic energy. They'll have only vibrational energy, and the distance is also less. So ultimately, you can say that force of attraction, based on force of attraction, we are having different states of matter. And that force of attraction is because of, again, the inherent nature of the molecules, which in again turn depends on the nature of the atom. So we will go back to the atom. Because of that is inherent nature of the atom, we see the force of attraction, and we see different states of matter. Okay. So this is, we can summarize. Okay. Now next, who will go? Okay, Bhumika, you please continue from there. From where, Anjali? 2 points you read.
Ma'am, exercise is there, ma'am.
Okay, very good. So you read first 2.
And what you have learned?
Sorry?
Ma'am, it's about summary.
Yeah, we have summary. That is what I thought, because I don't have the textbook here. So what Anjali, Bhumika, read 2 of the summary, 2 points in the summary.
Yes, ma'am. Matter is made up of small particles. The matter around us exists in 3 states: solid, liquid, and gas.
Very good. Okay, so this we discuss now. Okay, One property of solid which others two don't have. Bhumika, one property of
ma'am.
solid. Tell me one property of solid.
Particles of a matter are attract each other.
No, I'm asking a property. See, you said there are 3 states of matter. No. So I wanted the property of solid.
Yes, ma'am. Solids are have definite shape, size, and volume.
Very
They
good.
are rigid. Less
Exactly.
spaces, less spaces between the particles. More attraction between the particles.
Hmm.
They are
So actually,
compressible.
they
They
are
are not
compressible.
compressible.
They are not compressible. Okay. So we
Yes.
can say that they are rigid because the particles are very close by. We'll go to Danya. Danya, read the next 2 points.
The force of attraction between the particles are maximum in solid, intermediate in liquid, and minimum in gaseous.
Okay. So what do you understand from this point?
The force of attraction in a solid is very high, and the liquid compared to a solid in very low. In gas compared to a liquid, it is very low.
So liquid is intermediate. Okay. So read the next point.
The space in between the constant particles and kinetic energy of the particle are minimum in case of the solid, intermediate in liquid, and maximum in gaseous. Ma'am.
Okay. So what do we understand? What again?
The particles of a space is higher in gaseous, ma'am.
Hmm.
Intermediate space in liquid, ma'am.
Hmm.
Very low space in solid, ma'am.
Very good. So this is what we were discussing. Very good. Now Farhan, next 2 points.
Yes, ma'am. The arrangement of particles is most ordered in the case of solids. In the case of liquids, layers of the particles can slip and slide over each other, while for gases, there is no older particles just move about randomly.
Very good. So what did you understand from this? It is
In the solids, the particles are very tightly or orderly manner arranged, ma'am.
hmm.
In the liquid, the particles are some space and some space between them.
Hmm.
In the gaseous state, the particles move the randomly direction. It is adjusted in random.
It is moving in a random direction because there is no very less force of attraction between them. See, when you say the liquids, they glide over or slide over each other. So what is that property that we see? What do we call that? Liquid, no, the second aspect, no, the liquid slow, they say, no, they're gliding or sliding over one another. What do we call that? See, for example, okay, I'll give a hint. In case of solids, we say they're rigid. In case of fluids, what do we say, Farhan? Anyone can think and tell me that
Fluidity, ma'am. I'm fluid.
fluidity. Fluidity is because that they are sort of, because of their the force of attraction is not so much, so they can sort of flow. They can glide for flow, and fluidity is a property because of the force of attraction. Okay, very good. So next, Farhan, you read one property. Next one.
Yes, ma'am. The states of matter are interconvertible. The state of matter can be charged by changing temperature or pressure.
Hmm. So what do we understand, Farhan?
The state of matter can be changed with the temperature or pressure, ma'am, or heating or pressure in surface area. The matter of is changed.
We can change the states of matter, especially heat we use for solids. We use heat, and in case of gases, what do we use to change the matter? Farhan or anyone?
And
So if I
pressure.
want, we use pressure and also we reduce the temperature. So very good. So we have come to a very important aspect. And okay, so next, Madhumita, please continue.
Yes, ma'am. Sublimation is the change of gaseous state directly to solid state without going through liquid state and vice versa.
Very good. So why does sublimation occur? Madhumita, can you think of an idea why it is directly going from a solid state to a vapor state? Anyone?
Can I?
Okay. Lakshmi.
Ma'am, evaporations of sublime compounds takes place easily.
Okay. Okay. Now, Aishwarya,
Yes, ma'am.
why this evaporation of okay, we cannot call it we call it a sublimation. A sublimation is we are taking solid, when you heat it becomes a vapor. Why does it occur? Okay, I'll take an example of camphor or ammonium chloride.
Naphthalene
Why
ball,
does
ma'am.
it
Naphthalene ball.
naphthalene ball? Okay, why does it sublime? Why does it go directly to the gaseous phase?
They are volatile component, ma'am.
They're volatile. Okay, now I want Aishwarya to think and tell me why are they volatile? Okay, Anjali, any you can think of some answer? Why are they volatile? Okay, anyone? Why are they volatile?
Ma'am, they have low boiling point.
Actually, yeah, they have very low melting point. When they melt, see, they melt and they directly go into the vapor phase. That even if naphthalene balls, you keep it in one cupboard or you just leave it open. After some time, do you see that naphthalene ball would have slowly, it would have it would have sort of evaporated. You can only get the smell, and finally after some time the ball will become smaller and smaller and smaller. So at a very low temperature there is a change of state from solid to the vapor state. Even camphor. Okay, so this is an example of we call this as, what do we call this? We call it as, this process of conversion of solid to vapor is called as, just now Madhumita.
Sublimation. Evaporation.
Evaporation. What is the difference between evaporation and sublimation? Who said evaporation? Let us discuss that. Farhan told evaporation. No, because this is a very important thing. This is something very fundamental. What is the difference between evaporation and sublimation? Anyone can tell me?
Ma'am, can I?
Akash, who is it? Madhumita. Okay. Tell
Ma'am,
Madhumita.
a change of state directly from solid to gas without changing into liquid state is sublimation, ma'am. The change of liquid into vapors at any temperature below its boiling point is evaporation, ma'am.
Very good. So below the boiling point, if water changes from the liquid state to the vapor state, we call it as evaporation. But if you're nicely heating, if you're taking water and nicely boiling, then that point, at a boiling point, it will evaporate. But in normal temperature, what happens? Water molecules at the surface, they will they'll take the energy from the atmosphere. They'll go to the higher energy state, and then they're able to break the force of attraction and go into the atmosphere. So without boiling itself, they can evaporate into water vapor. See, boiling occurs at what temperature, students?
Boiling of water, no, ma'am.
Boiling of water.
100
Correct.
degrees.
Yeah, good question.
100 degrees Celsius, ma'am.
Okay.
In Kelvin, 373 Kelvin. 373 Kelvin, ma'am.
373 Kelvin.
Yeah, excellent. Okay, so now in this temperature, maybe now it is 28 degrees centigrade. If I keep, there was an experiment, you keep water, means that water will evaporate slowly, it will evaporate. And this water will evaporate from oceans, it will evaporate from sea, and then it will go up and it will become a cloud. And afterwards, then it will condense to give us the rain. Okay. Any doubts so far? Okay. So any more points? Next 2 points after Madhumita. I think.
Ma'am, I am ready.
Who is ready? Amog is ready.
Yes, ma'am.
Excellent. What are the next points?
Boiling is a bulk phenomenon. Particles from the bulk in bracket hole of the liquid change into vapor state.
Excellent. So what do you mean by that, Amog? What have you understood?
Miss, it means when the water starts boiling, it boils entirely.
It's a bulk phenomenon. You must have seen when water is kept in the baking tea, no? When water, you'll see the whole water will be sort of, you can see bubbles coming out and steam coming out. So it is a bulk phenomenon. So at 100 degrees, this will the water will get converted to water vapor. Okay. And we were discussing, if you keep a thermometer, even though water vapor is being formed, the temperature will remain 100 degrees. More and more steam is being formed, more water vapor is formed, but the temperature will continue to remain at 100 degrees centigrade till the water has sort of evaporated. Okay. Okay. Continue, Amog.
Okay, ma'am. Evaporation is a surface phenomenon. Particles from the surface gain enough energy to overcome the forces of attraction present in the liquid and change into the vapor state.
Very good. So what did you understand, Amog?
Miss, evaporation takes place only on the top surface of the water.
Correct. It takes place only on the
Miss,
surface.
Yes. Miss, and only the top surface of the water will change into vapor state.
It will change into vapor state. How is it able to change into vapor state, Amog?
Miss, by absorbing heat.
Yeah, it will absorb the heat from the atmosphere, and that then its kinetic energy will increase, and that will be able to break the force of attraction with the water molecule, between the water molecules, and then it will escape into the atmosphere as vapor. Very good. Okay. So next, I think it is Mahalakshmi. Mahalakshmi, please read.
Yes, ma'am. The rate of evaporation depends upon the surface area exposed to the atmosphere, the temperature, the humidity, and the wind speed.
Very good. So these are the 4 factors that affect evaporation. We were discussing, you can keep it in a small container inside a cupboard. You can see it will take more time to evaporate. If you keep it in a saucer, there was, I think, an example, like drinking tea in a saucer. Why is it easier? So these are the 4 factors. So, okay, very good. Mahalakshmi, next point.
Evaporation causes cooling.
Why does it cause cooling, Mahalakshmi?
Ma'am, substances needed heat to evaporate, ma'am. The substances get energy from the surroundings and change it into vapor, ma'am. That makes the surroundings cool.
Very good. So it needs energy. So it takes energy from the surroundings. So as a result of which its surrounding will become cold because it is losing energy, and this is taking energy to get converted to water vapor. Very good. Okay. Good. So next person, I think it is Pawan. Please read.
Latent heat of vaporization is the heat energy required to change 1 kg of liquid to gas at atmospheric pressure at its boiling point.
Which one again? Please read again. Latent heat of?
Latent heat of vaporization is the heat energy required to change 1 kg of liquid to gas at atmospheric pressure at its boiling point.
Okay. Next point.
Latent heat of fusion is the amount of heat energy required to change 1 kg of solid into liquid at its melting point.
Okay. So what do we understand from, okay, we'll take first fusion. Pawan, what do we understand? What is from latent heat of fusion mean? What does it mean? Okay, what is fusion, Pawan?
The process in which solid convert into liquid at
Excellent.
atmospheric pressure.
Yeah. So what is that point called as? The temperature called as? Pawan, the temperature at which a solid gets converted to liquid. What is that called as?
Fusion, ma'am.
That is, see, fusion is a process. So in common words, we say melting. No, melting. The process is called as fusion. So fusion, so the temperature at which, that is when you're heating, the temperature at which it melts or fuses is called as, what point is it? Isn't it called melting point? Pavan? So melting point is the temperature at which solid will melt to the and melt and
liquid.
yes, it will become a liquid. So what do we understand by latent heat of fusion?
The heat energy required to change 1 kg liquid to gas, ma'am. Yeah.
No, fusion. I'm taking
1
from
kg solid to liquid, ma'am.
So
at its melting point.
At its melting point is called as latent heat of fusion. That means it will take energy. So ice, if your ice will melt to water, it will go, even though you're slowly heating, the temperature will be continuously 0 degrees centigrade, even slowly till all the ice melts to water. So that much energy water will have. So that energy is called as latent heat of fusion. So in the same words, Pavan, what is latent heat of vaporization?
The heat energy required to change 1 kg liquid to gas, ma'am. At atmospheric pressure at its boiling point.
Okay, but what is boiling point? Very good answer. What is boiling point?
The process in which the liquid boils to water vapor.
It is a temperature at which liquid will
Liquids
converted.
start to boil.
Yeah, so we can say it is a temperature at which liquid gets converted to the vapor phase. At 100 degrees, it will, in the example, water will vaporize to water vapor. Okay. Okay. So here, in case of, I have a question before we go to the question answers. Which has more energy, steam or water, boiling water?
Steam, ma'am.
Steam. Steam.
Steam is having more, it is more having more energy when compared to water. Very good. Okay, so we have now looked at, we have had a summary of all the aspects that we have studied in this chapter. Now we'll go to the question answers. So we will go back to Mantesh. Can you read the first question?
Ma'am, there are some measurable quantities.
Okay.
Some measurable quantities.
Very good. That we will take up.
Quantities
so,
and their unit.
Their unit. That is very important. Pavitra, please read.
Yes, ma'am. Convert the following temperatures to the Celsius scale.
No, we'll go back to the table. There's a table, no, very important table, unit.
Yes, ma'am. Some measurable quantities and their units to remember. Quantity, temperature, unit Kelvin, symbol K. Length, meter, symbol M. Mass, mass, weight, volume, density, pressure. Kelvin K, meter M, kilogram kg, Newton N, cubic meter M cube, kilogram per cubic meter kg, meter.
Okay,
Per
can you
cubic meter.
From the beginning, can you read what is there on the left hand side, then read the particular, that is the symbol also. The quantity, that is You read and the unit and the symbol, all the three. Okay.
Kelvin, K. Meter, M. Kilogram, kg. Newton, N. Cubic meter, M cube. Kilogram per cubic meter, kg per
No, it's okay. So go back to the measurable quantity. What is that? What is that first one? Kelvin is for temperature. No. So start with that.
Yes, ma'am.
Start with that. Then give this one name and then the symbol. Unit and
Yes,
the
ma'am.
symbol.
Temperature, Kelvin, K. Length, meter, M. Mass, kilogram, kg. Weight, Newton, N. Volume, cubic meter, M cube. Density, kilogram per cubic meter, kg per cubic meter.
Centimeter cube. Yeah,
Pressure,
centimeter.
Pascal, P.
Pascal, P. Okay. So this we have come across. We have come across Kelvin. We have come across in density. We have come across. Then also we have seen about pressure. Okay. So this we have come across. So this is very important. The units and the symbol, they are very important for us to remember. Okay. Right. So now we will go to question answers. Any doubts? So far, no doubts.
Is there the latent heat of sublimation?
Latent heat of sublimation. I think, see, the melting point will be so low that you just supply some energy, that is enough for it to evaporate. So that's a good point. I think that melting point, it's a very good point. I think I have to refer, but that melting point we can see. And that latent heat of fusion, what is it? We can just have a look. See, you don't know whether to call it as latent heat of fusion or latent heat of vaporization, isn't it? Because melting has to happen, but during melting it is getting converted to vapor. So it must be very low. Let us see. I'll just check and come back.
Okay, ma'am.
Any other questions? Okay. So now we'll take up the question answers. So I think Pavitra over Pooja. First question.
Yes, ma'am. Convert the following temperatures to the Celsius scale. First one, 293 Kelvin to degrees Celsius. So 293 minus 273, it is equals to 20 degrees Celsius, ma'am.
Excellent. Okay. Next question. Next one.
Second,
Another one is
second one, ma'am, 470 Kelvin, ma'am. So 470 minus 273 is equals to 197 degrees Celsius, ma'am.
Okay, very good. Excellent. Okay. So I think only 2 questions are there, no, Pooja?
Yes, ma'am.
Okay. Next, Pratiksha, next question.
Convert the following temperatures to Kelvin. As we know, 0 degrees Celsius is equals to 273. 25 degrees is equals to 25 plus 273 K is equals to 298 Kelvin. Second one, ma'am, 373 Celsius. That is 373 plus 273 Kelvin is equals to 646 Kelvin.
Okay, very good. Okay. Next question, Prerna.
Give reasons for the following observations. Naphthalene balls disappear with time without leaving any solid. Why?
Okay. Why? What will be the answer?
Ma'am, naphthalene balls disappear without leaving any solid behind because they undergo the process of sublimation where the solid directly changes into gaseous state without passing into liquid state. So it doesn't leave any solid behind.
Very good. Excellent. Okay. So second question, second due reason.
Ma'am, we get the smell of perfume sitting several meters away. This is because of diffusion, ma'am. The particles of the perfume in the air diffuse fast in gases, so we can smell it sitting several meters away.
Yeah. So they actually, from the perfume, when you spray, that vapor, it will mix with the air and it will travel very fast because it has a lot of kinetic energy. They have diffused fast and we are able to get the smell at a distance. Issue will take Samiksha. Can you read the next question?
Yes, ma'am.
Hmm.
Arrange the following substances in increasing order of force of attraction between the particles: water, sugar, and oxygen. Then the answer is sugar, water, and oxygen, ma'am.
Sugar, water, and oxygen. So what is the reason? I mean, what would you say? What is the? I mean, how did you arrive at this? Sugar is a solid.
Force of attraction between the particles. In a solid, it will be more, and in liquid, it will be intermediate, and in gas, it will be minimum.
Very good. Okay. So next question.
What is the physical state of water at 25 degrees Celsius? The water will be at liquid state, ma'am. And 0 degrees Celsius, the water will be at ice. And 100 degrees Celsius, the water will be at water vapor.
Will it be at water vapor 100 degrees when I'm boiling? Will it be fully water vapor?
It will be started converting into water vapor, ma'am.
So you will have both water is boiling, and then you will have water vapor. So if you see means water you will have, and also water vapor, both liquid state and vapor state, till everything vaporizes. No?
Yes, ma'am.
So we can say both are existing, strictly speaking. Any discussion, any doubts on that? Okay. So at 0 solid, liquid at 25, and at 100 degrees, water is boiling and getting converted to water vapor. So it's existing in both the stages. Sachin, next question.
Give two reasons to justify. First one, water at room temperature is a liquid.
Why do you think water is liquid at room temperature, Sachin? What do you think? Any answer? I mean, whatever. See, sometimes when you answer, huh? Yes, Sachin.
It has a definite value but not definite shape. It flows at room temperature. It is not rigid at room temperature.
See what happens. No, at room temperature, it is more than 0 degrees. If it is 0 degrees, ice will melt into a liquid. At 0 degree, ice will start melting into a liquid. At room temperature, all the ice would have melted into liquid. So it is above the melting point. So it is in a liquid state. Okay, at room temperature, it is in a liquid state because it is above the melting point. Okay, if it had been say minus 0 or something, it would have been in the form of ice. So at room temperature, it is in the liquid stage because it has crossed the melting point. So all the molecules of water, they are in a liquid state. They are in a fluid state. Okay. So next question, Sachin.
Almirah is a solid at room temperature.
Yeah. Why is an Almirah solid at room temperature?
Because it has definite shape and volume. It is not fluid.
Correct. So it is having a definite correct. It is having a definite shape, definite size, and it is also rigid. And like how water was having, I mean, it did not have a definite shape, but it had a definite volume and it was fluid. Here it is a solid. In case of solid, it is having a definite shape, size, and it is rigid. Very good. Okay. Next, any questions are there?
Yes.
Please read. Shravan Kumar, next question.
Yes, ma'am. Why is ice at 273 Kelvin more effective in cooling than water at the same temperature?
Okay. Okay. What do you think is
ice at 273 Kelvin is less energetic than water? It is because of the difference in a latent heat of fusion which is present in a water at the same temperature in the form of extra energy, ma'am.
excellent? So it is because of latent heat of fusion. So water will still have, it has that energy. So as a result, it is not able to cool as much as ice. So yeah, the cooling always takes place by like from what you call it, from higher temperature to lower temperature. This is already having so much energy, it will not lose energy, so cooling will not take place. Excellent, very good. Okay, any other questions? Shravan Kumar? Okay, I think Sanjana has come back. Sanjana, we'll go to her. Sanjana, any other question left? Okay, I'll come back to Shravan Kumar. Shravan Kumar,
Yes, ma'am.
any other question after that?
Yes, ma'am.
What is it?
What produces more burns, boiling water or steam?
Which
Steam
produces more?
more.
Yes.
Steam produces more burns than boiling water because steam has more energy than boiling water present in it, the form of latent heat of vaporization.
Excellent. Very good. Okay. I think one more question must be there. Shweta?
Yes, ma'am.
Next question is there.
Yes, ma'am.
Please read.
Name A, B, C, D, E, and F in the following diagram showing change in its state.
Okay. Okay. Now, okay, can you tell me what is A?
Ma'am, A is fusion.
A is fusion. Okay. Then B?
Vaporization. C is condensation. D is solidification. And E is sublimation. F is also sublimation.
Yeah, the book they are given sublimation, but in that experiment, no, remember that we had that funnel experiment with ammonium chloride. We see at the top this ammonium chloride vapors will deposit. So another word is deposition. Okay, excellent, very good. Excellent. So all these are clear to now everyone. No, any doubts you are having, students?
No, ma'am.
Okay, no one is having any doubt. Everything is clear. See,
Yes, ma'am.
I always used to joke. Okay, I used to always say that if you have understood either in a class, if they say they've understood, I would tell them, okay, we can start discussing in detail the questions anyway. Okay, I don't know. I had actually pictures of, one was dry ice, solid carbon dioxide. Another picture was of how fishes breathe. How they breathe with the help of the gills. So what fish will do first is it will close the gill. Gill has one like it's like a ear. It will close the ear and it will take water through the mouth. And then after that it will close the mouth and open the ear. So the water will go out through that ear. When it is going out through the ear, the oxygen that is present in the water will diffuse into the blood, because gills will have a lot of blood supply. So we can see the diffusion. Anyway, next week I will try to solve the problem and then we can see. Third picture I had was I wanted to show how clouds are formed. So clouds means water will evaporate from the sea, river, water will evaporate, it will go up. It is light, it will go up. And then dust particles are there, or some any particles. It can be either from some particles from volcano or some bacteria, whatever may be a solid particle. On that, this water will start depositing. Water vapor will start depositing. And then it will form ice crystals, especially if there is a change in the atmospheric pressure. It will form small water vapor. It will form water droplets, and more water vapor will join together and form cloud. So that cloud, when the air gets saturated, means it cannot hold any more water vapor, it will come down as rain. So that was another picture that I had kept. And the fourth picture I wanted to show was regarding this plasma. So plasma, the difference between fluorescent lamp and neon lamp. So neon lamp will have one color. It will have a color red, blue, like it will have different colors. Fluorescent lamp, because the bulb surface is coated. Inside helium is there, but the bulb surface is coated with phosphor. It will fluoresce. You see that fluorescence. You don't see the color. You see that white fluorescence. So that was the five pictures that I had kept. So it is okay. What we can do is next time, next class, when we get this one, we can see that we can see the slideshow, and then we can go to the next chapter. So the next chapter is on mixtures. So next chapter, the mixture word indicates that this matter. For example, we saw solid. Solid, the matter, all the particles were arranged in an orderly manner, isn't it? Suppose in between, if you are having some other a particle present, okay. See, for example, we are having, let us take up, we are having iron. Iron, it's a solid. You are having iron particles. In between, copper is present. Okay, and that together they will have, they will become an what is called as an alloy. So actually, mixture is you are having mixture of particles present. This you have already studied, no? All of you, your teacher has already taught you, isn't it? Yes or no?
Yes, ma'am.
You have studied.
Yes, ma'am.
You have studied. So we will go through it with more some examples. Okay. So I think now it is time. Any doubts so far in this first chapter? Anything you want to know? Okay. I will ask you a question. I said fish, no, it will breathe through gills. Okay. Now dolphins, whales, how do they breathe? Anyone? How does a dolphin breathe? Aishwarya, can you tell any idea how dolphin breathes?
Gills, ma'am.
Does it have gills?
Ma'am, lungs.
Lungs.
Does it have lungs? Does it have lungs? Why do you say it has lungs? From air. Somebody else wanted to say. Who is it? Pooja? Anyone else?
Ma'am,
Yeah.
ma'am.
Sanjana says it is from air. Any other answer?
Ma'am, can I say?
Who is it? I can't make out yet.
Anjali, ma'am.
Okay. What is your answer?
Ma'am, dolphin come out from the water, and they take air from the surroundings, and then they go to the water, ma'am.
Excellent. Yeah. So yeah, correct. As like you all told, like it breathes from the air. So that is why dolphins keep coming into the air. It will take the water, then it will go back into the. It will take from the air, and then it will go back into water. So dolphin is an example of a mammal. So usually you have read about mammals, warm-blooded animals. You have read? No. Okay. So that means no one is answering. That means you have not read. Anyway, so here the point is, so dolphin and whale. Even whale, if you see, picture of whale, it has some two snouts, like some opening through which it will be giving out. You can hear a lot of sound. Any picture you have seen of a whale?
Yes, ma'am.
So it takes from the atmosphere. It takes the oxygen from the atmosphere. So these are examples. Though they are fishes, they are taking air from the air that is dissolved in the oxygen dissolved in the atmosphere. From air they are taking oxygen, and not from water. Okay. So students, thank you very much. Okay. See you all. Bye. Have a great day.